Hey everybody, it's Dustin over at Geekmatics, and I just hit 1,000 subscribers, so thank you. I'm very excited about that. So today what we're going to do is we are going to go over how to use a DC power supply to diagnose an iPhone and an iPad. For that, we are going to use an iPad 6 that has no signs of life whatsoever. So we're going to start with where I would start, which is by plugging in the charger and kind of going all the way to the end to a working iPad. So without further ado, let's get started. Okay guys, so as I just stated, first step here is to plug in the iPad to see the current draw via the charging ports. And if we look here, we see like nothing, like 5 milliamp. 13, it jumps at 13, 18, 19 there for a second, then right back to the dang near nothing at 5 milliamp. And if we look at the screen, nothing. It is black. All right, so no charging logo, nothing like that, or Apple logo. So the next step is here to take the board out of the housing actually and connect a DC power supply. Okay guys, one of the things I like to do on iPads in particular is to quickly inject voltage to kind of see if I get any current draw before prompt to boot, which I shouldn't normally on an iPad. So in order to do that, I'm just going to remove my multimeter probes from my multimeter and move them over to my DC power supply. Then I'm going to check to make sure my current is somewhere safe, so I'm going to change it, turn this down to 4.3 volts, and 3.5 for the amp is okay. And now I'm going to inject the voltage on the positive and negative pin with my multimeter probes. Okay, I'm also going to kind of click here to make sure, if you look at my DC power supply, you'll see that when I do touch these two together, I do get a short, which completes the circuit, which means that this is going to work if there is a short. I get nothing. 0.01, which is weird. I would expect to see straight nothing, but okay, that's pretty much nothing as it is. Alright, so now what we're going to do is we're going to prompt to boot the iPad. We're going to ask the iPad to turn on, but I'm not going to use my multimeter probes. I can't talk today. I'm not going to use my multimeter probes to determine that. I'm going to put those off to the side, and I'm going to get my little alligator clamps and clamp them onto the board. That way I have my hands free to do other things. Okay. Now I have this iPower Max, but if I didn't have this, I could literally take two pieces of wire and attach it to a clamp or whatever to clamp it to the battery. If I was really desperate, I could solder it to the battery connector. There's many different options to do this, but this is the way I prefer. And I will go ahead and connect this to my DC power supply now. And then I will get a little anti-static bag from MS because they give me so many. Got a drawer full of these bastards. Alright. That's on there. You can see I'm only touching the positive pin. I'm not touching any of the battery data line pins. So again, those are the smaller pins. And then on my negative, I'm just going to connect it anywhere on the that I know is ground on the housing itself or on that plate. Alright, and now you'll see we have the same behavior on our DC power supply, which is a 1 milliamp draw to nothing. And how I'm going to prompt to boot this iPad is simply by plugging it in. I could short the power pin, but on an iPad that's got a charging port soldered on it, a normal iPad behavior will turn on when I plug it in, right? So I'm just going to plug it in to prompt to boot. And immediately I get a 500 milliamp draw until I unplug it, and then I get a 925 milliamp draw, which tells me that is a short. Normal fluctuation on an iPad or an iPhone is going to be low at first and kind of steadily build up, and it fluctuates rapidly. And this is kind of steady at 920 milliamp current draw from the battery. Okay, and again I'm going to plug it in so you can see. If I plug it in, it goes back to about 430 milliamp draw, and that's because wherever the short is, it's consuming power from the charger as well. So it's still, overall, it is still drawing 900 something milliamps, okay? But it's just when I plug it in, it's using some of the power from the charger, some of the power from the battery, which is this, and that's why it subtracts there. All right, so that is a short. So what's our next step? We're going to turn this off. Our next step is to find the shorts. Okay, so we're going to remove this. We are going to pop this shield off, and I can tell you it's warm. The board itself is warm. Okay, so that tells me that this is going to be definitely a short. Confirm my suspicions. There's some tweezers that I don't necessarily care about to pop this plate off. Don't want to obstruct your guys' view here. There we go. Boop. Take that, put that to the side. All right, and what's our first step when it comes to trying to find issues with iOS devices or board issues? Is, other than the 10 steps that I've already been through, the other first step is visual inspections. All right, one of the things I wanted to go over before I did the visual inspections, or we did the visual inspection together, is essentially what just happened there and what I saw, what I expected to see, and what would be the cause if it was something else. So you saw that I injected voltage, and when I injected voltage before prompt to boot, I had no current draw. There was nothing there, right? And then after prompt to boot, I got like a 900 milliamp draw, which is a lot. Okay, that tells me there's a short. Now, if I had voltage before I prompted to boot, that would tell me something before the PMIC was the issue, okay? Because the PMIC is turned off, it's not supplying those voltages when in an off state, right? So if I have current draw before prompt to boot, that tells me the issue is before the PMIC on the schematic or on the power rails, etc., right? Now, if it's after prompt to boot, then that tells me that the issue is something after the PMIC on the schematic, okay? So I can skip over main, etc., right? I can look at other things. Now, if, and mind you, over time, when with experience, you guys will be able to identify these current draws rather quickly. So instead of spending an hour and a half on a device, you'll be able to knock one out in about 5 minutes. And that's the greatness of experience. So don't give up just because you don't register it right away. You will over time. All right, so let's go ahead and do the visual inspection now. So we are going to go ahead and take a quick look at this board through the scope and see what we get. Get everybody focused here. I'm in focus. Are you guys in focus? Beautiful. All right, I guess we could remove this little, look how dirty my tweezers are. Filthy. Move that out of the way. And we're kind of looking at for any type of components that look discolored, maybe are burnt in any way. Something you would normally see with a short or a shorty capacitor, which are these things. These kind of look off, but that's because they have underfill on them. Everything seems to be looking good and in order. Hopefully nothing around the CPU is damaged. No, everything looks pretty good. Maybe a NAND shorts. One thing that we're looking at here is, let's do the visual inspection, then we'll go over that. I think everything is okay on the visual inspection. It looks pretty decent. So, what's the next step now that we've passed visual inspection and we know there's a short after the PMIC? We know there's a short, right? So what is the next step? Normally it would be, for me anyway, it would be to open up ZXW and kind of see what rails are after the PMIC to go after those power rails. Now, if we look at ZXW for the iPad 6, it's going to be pretty non-existent. Let's go ahead and switch over to that now. Okay, so this is the iPad 6 on ZXW. And there is no line names, right? That doesn't even tell me that these two pieces together are a coil. I just kind of have to assume that by looking at the board. If we look at caps here, you would think because both of these get red, they're the same piece, but that's not how it is. These are actually one capacitor. This is a capacitor, or honestly, it could be this here over here, and that's probably actually what it is these two to these two to these two. So it's harder to look at. It's very empty. It's still very useful, don't get me wrong. It tells me what's connected to each other, but it doesn't give me an idea of, okay, well, this is after the PMIC and blah, 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 because just because it's connected to the PMIC doesn't mean it's after the PMIC. It could still be before. So in this instance, ZXW is not going to help us terribly much, at least in this point of the diagnostic stage, okay? Now that ZXW hasn't told us very much about where our problem could be, the next step is to just kind of go in blind, unfortunately, and start probing around the PMIC, start probing outwards around the PMIC, and see if we can identify that short manually, and then we'll go from there. All right, so let me get my multimeter ready. Okay, so my multimeter actually beeps when I have a short to ground, okay? So you will be able to hear that beep, and that will tell you that that line is short. All right, so let's start probing around the PMIC. All right, that could be a ground, so that could be normal. Good, okay, so that line is good. We're just gonna kind of just probe around everywhere. And if I have a cap that has a short on both sides, that's when I start to worry. Good, good. Ah, look here. We have a cap that has a short on both sides. Now we have to be careful, because a lot of these caps near PMIC are like for SoC CPU or some CPU data line or something like that. And those capacitors are normally they're very, very low resistance to ground. So if you have maybe not so nice of a multimeter, you'll get like a full short, or it's showing a full short when in fact it's not short at all. So you just kind of have to be careful. And again, that's kind of when experience comes into play, and when you have a better multimeter, you can kind of see how close it is to the PMIC, how they're grouped together, to kind of see if it's like a data line, or if it's a power rail for a very low resistance power rail. And those normally are around the PMIC. So this is kind of further away from the PMIC where I found that short. I do not think it's going to have anything to do with that. And on my multimeter, I do have a Fluke. What is it, the 117, I believe it is? Yes, the Fluke 117. And that is, it does show on those other rails like 0.056 or 0.034 or whatever. So it does not show a full short for me. But just be careful with that if you don't have the world's nicest multimeter, okay? Now that we found our short, what we would normally do is we'd go to ZXW and we would say, okay, this line is main, and main normally has 4.3 volts, and we're going to apply 4.3 volts on our DC power supply on that line directly, and we are going to inject the voltage and see what gets hot, pop off whatever gets hot, and we're good to go, right? But as we already know, ZXW doesn't have a lot of information for this. So when I'm looking at this board, and I'm looking at this line that is short, I don't really have any information of where it goes. Now, if we're looking at this line closely, though, I think we can have an idea of where our bad guy is, this guy. But we're still going to go through the procedure on how we got there, because we missed it over visual inspection. I'm not even sure how I missed that on visual inspection. I mean, he just says standing out of the pair of 8 caps, it is clearly the bad one. This is going to be an easy repair, right? Okay. All right, so, but we're still going to go through the process. What's our next step? So let's pretend that cap is, we don't know that cap is bad, okay? What would our next step be? Okay, if I didn't know what voltage was supposed to be on the line, but I'm supposed to inject voltage into it to find a short, right? How would I do that? Well, I would start very, very low. Okay, this might be a backlight line, and which means sometimes it needs 40 volts to run, right? And it also could be 1V05 or 1.5 volt 05 volts line, and that's very low, and I don't want to inject 40 volts into that. So what I do is I act like it's the most sensitive line in the world, and I start on my DC power supply with a very, very low voltage. So I would go to like 1 volt, I would inject it in 1 volt, and then if I didn't see anything getting hot, I would go up to 2, 3, and so on, and look at what my current draw was, okay? Now, since I guess I should still kind of go over the injecting the voltage here, even though we know what our problem is, just so we can kind of see how I'm using the DC power supply. So let's go ahead and do that, and we'll pretend that we didn't just see that cap being darker than the rest. Alright guys, so what I'm going to do here is again remove my multimeter probes from my multimeter and put them on my DC power supply. Turn on my DC power supply, and this time again I'm going to lower the voltage, lower the current too. Let's try 1 and 1. Okay, and we'll do the touch here. Good, we have the result we were expecting, and I'm going to put gloves on because I'm going to use freeze spray. And I have a thermal camera, guys, but I find the freeze spray quicker, easier to handle. Thermal camera I literally only use when the short is very difficult to find, very low current draw. It does come in handy. I'm not saying not to buy one, but the freeze spray is always what I grab. The only thing I don't like about it is the way it tastes. If you touch anything and then have your hands anywhere near your mouth, it's so awful. Well, I use canned air and I hang it upside down, so it has like that bitter taste to it. But enough with that rant. As I put on my gloves, we will go ahead and get to our problem area. What is it? Here it is. And well, before we do this, hold on, we're gonna ourselves. Let's take a look at ZXW and figure out what is short. So if we look, this is the orientation we have the board. No, flip it over here. That's still not the orientation. Still no. Oh, here we go. There we go. This is the orientation. So our short is down here. So it looks like the inside row is going to be our positive, okay, and the outside row is our negative. All right, so we're going to inject on the inside row. Put some freeze spray on the board. Tip our can back over and blow some air on it. Let's get a little frostier. I like to make it look like it's first snow in Canada. There we go. Put that to the side. And now we inject. And look, that bad boy doesn't want to get hot. It took some time, but it got hot. Right? You see it? Now, let's pretend we didn't see that. Let's raise our voltage here to about, say, 3 volts. All right, and let's see if it gets hot any faster. Let's see what the difference is. Add some more freeze. Again, nice frostiness over there. Beautiful. Oh, hold on. My current's still low. That would be probably why it's taking so long. Not because of my voltage. Why did I change that? Let's bring this back down to 1. Let's see what happens. Boop. You see that? You see how fast that was? Oh, come on. Refreeze. Bring this over here. I don't want to touch anything. Bam. Got hot right away. So that is our bad cap. So what's our next step? Dry this off. Our next step is to let that get back down to room temperature, because my next step is to put heat on the board, and I do not want to go right from hot to cold like that. That damage the board. Okay, so we're gonna let that cool, or not cool down. I'm gonna let that warm up, I guess, for a second, and then we'll be back to it. Okay, so while we're letting that board warm up for a minute. I always used to saying cool down. Warm up in this case. While I wait for that board to warm up for a minute, I kind of wanted to hit a question that I get asked a lot, and is do I have to put that cap back? Sometimes yes, most of the time no. It really depends on the scenario, and that's where board views and schematics really come in handy. Like if we take a look at, let's see here. If we take a look at the board view software, ZXW, we will see that on this particular rail that was short, the capacitor that was short, I believe it's this one here, is a leg on ground, and there are many other capacitors on this line. So in this particular case, I would say that it's not necessary to put that cap back, and the iPad will live a long life and healthy life without that particular cap, right? In some cases, and just because it has a leg on ground does not mean it's not needed. And that's one of the things I hear experienced techs say often is, oh, if it's got a leg on ground, you don't need it. And I was one of those people up until a few months ago when I had a MacBook that I had this particular circuit that was not working properly, and the problem was a capacitor that I had removed, and I worked on this MacBook for 2 days and didn't realize the issue until I looked at the schematic closer and realized that, hey, just because it had a leg on ground doesn't mean it wasn't important. And as soon as I put that capacitor back, the MacBook worked. So that being said, yes, just because it has a leg on ground, or yes, 90% of the time, 99% of the time when it has a leg on ground, you can remove it, don't have to replace it, it's not an issue. But there are some instances where you do have to replace it. So if you are not sure or it's a toss-up, then replace it, okay? But in this instance, I can tell you I don't have to replace that capacitor. It will work fine. Now this board should be, yeah, it's about at room temperature. So now what I'm going to do next is go ahead and remove that cap, okay? All right. Now what I'm going to do is I'm going to apply the hot air. Now again, I'm not replacing this cap, so I don't necessarily care about a pad being torn, but I am going to apply some hot air just to kind of make it easier. Well, I was thinking I could apply pressure, but I think it's going to knock that other cap. Oh, look at that. Nope, comes right off. A little bit of hot air, and it'll come right off. Boop, just like that. Bam. Now, without applying any power to the device, the next step is to go ahead and see if that line is still short. Alright, and in order to do this, we're going to put our probes back on the multimeter. We're going to touch them together, make sure, yes, we get the beep we are looking for. We're going to, again, probe here, and we get a reading. Although it's supposed to be black probe on whatever I'm trying to test, but that's okay. Both will show a short in that case. And I don't. Alright, beautiful. I don't have a short. Awesome. Now I think this iPad will turn. Alright, so our next step here again is, now that we've confirmed that line is not short, to see if the iPad will boot. So I put it back in the housing and screwed the battery in, and I'm just going to plug it in to prompt it to boot, and we'll see what happens. Okay, that's much better than we were having before. Oh, look at that dead battery icon, 2.4 amp draw. That iPad is fixed. Alright guys, that's just about it. You know, we just kind of went over how to use this fundamental tool, a DC power supply, and how to use it to diagnose this iPad. We figured out how to locate shorts. We kind of went over how to use the XW. We went over a good amount today. I want to thank you again for getting me to 1,000 subscribers. That's awesome. That's a big milestone for me. I'm very happy about that. And as always, I hope I taught you something, or I hope you learned something. Have a good day.